Hello my dear friends, you are most welcome in this beautiful lecture. Today I am going to teach you about the isomerism. What do you mean by the isomerism and the different type of isomerism available in our chapter. Actually it is very interesting topic of journal organic chemistry. Iso means same and merism means unit, having same molecular formula. So what is the exact definition of isomerism? Now, before to start the isomerism completely, I want to show you one more figure. You see, the twins, externally, look-wise they are similar, but about the attitude, according to their behavior, internal structure, they are different. So we can call them isomer of each other. Now, what is the exact definition of isomerism? Actually, when the compound having same molecular formula but different physical and chemical properties are known as isomer of each other. Please note down. Do you have pen paper with you? No? So please bring pen paper with you and note down the definition. What are isomer? Isomer are the compounds having same molecular formula but different physical and chemical properties are known as isomer. You can see the structure. Actually, the first structure that is of the glucose and it is for the fructose. So molecular formula of glucose and fructose that is C6H12O6. Both have same molecular formula, but you see there is a aldehyde group available and there is a ketone group with the fructose. You can see this structure. And similarly for this there is 3 carbon in this compound that is C3H6O. We can write C3H6O. Having 3 carbon, 6 hydrogen and 1 oxygen, so it is the acetone and another one is propanol, that is the aldehyde. So these are isomer of each other. Now let us proceed. What is the definition? Compound having same molecular formula but different physical and chemical properties are known as isomer, and this property of the compound are known as isomerism. Let us move for one more example. You can see isomerism. It is divided mainly in 2 parts. One is structural isomerism, number 2 is stereoisomerism. Structural isomerism means the compound having same molecular formula but different structure known as structural isomer. And what about stereoisomer? The compound having same molecular formula but the arrangement of atom, ion or molecule in 3D space that is different, known as stereoisomer. In this lecture we will discuss about the structural isomerism. Structural isomerism further divided into 5 to 6 types. Number 1 is chain isomerism. Number 2 is positional isomerism, you can see. Number 3, functional isomerism. Number 4, metamerism. 5 is tautomerism, and next is chain isomerism, ring chain isomerism. While stereoisomerism divided in 2 parts. The one is geometrical isomerism and the last one is optical isomerism. Now let us move and discuss one by one. The first one is chain isomerism. What is the chain isomerism? The compounds having same molecular formula but different number of carbon chain, they are known as chain isomer of each other. You can see the example. Suppose we have C4H10. C4H10. How you will draw the structure of C4H10? We can draw the structure of C4H10 like this. It may be butane, that CH3, CH2, CH2, CH3. Or it may be CH3, CH single bond, CH3 and maybe CH3, 2-methyl propane. So in first one there is a 4 carbon present in the main chain, and the second one there is a 3 carbon present in the chain. So these 2 compounds having same molecular formula C4H10, these are chain isomer of each other. Now let us move for another type of isomerism, that is position isomerism. It is very interesting. such compound which has same molecular formula, but the position of side chain or either functional group that is different. They are known as positional isomer of each other. Positional isomer. If we change the position of side chain or the functional group, suppose we have very simple compound that you see the structure. The first one is 3-ol, pent 3-ol. Second one is pent 2-ol. Last one is pentane 1-ol. So the position of OH group is different. At the first one, it is at the third position. Second, there is a second position, and then on the last compound, the position of OH group at carbon atom number 1. So these are different to each other. I can give you one more example. You see, suppose we have the compound like this. We have benzene ring, and there is OH group situated at the top, and one more OH group at this position. This compound 1,2-diol, clear? And you see the compound, the position of OH group at the top and here at the third position. Generally it is known as catechol. Catechol. It is generally known as catechol. Catechol. And here it is known as resorcinol. Resorcinol. And if we change the position of OH group from third to fourth, then it will be hydroquinol. Clear to you? Now let us move for the next isomerism, that is functional isomerism. It's a very simple definition. Compound having same molecular formula but having different functional group are known as functional isomer of each other. For example, C3H6O. We can make C3H6O as a acetone. There will be keto group CH3 COCH3, and another may be CH3 CH2 CHO. So there is an aldehyde group having same formula. For example, we have CH3 CH2OH. What is the molecular formula of this compound? That is C2H6O. One is ethyl alcohol, another may be CH3OCH3, ether, methoxymethane. So alcohol is the functional isomer. Alcohol is the functional isomer of ether, and ketone is the functional isomer of aldehyde. Similarly, if we have ester as a compound, its functional group will be acids. Please note down, highly important. Now let us move for the next isomerism, that is metamerism. Metamerism, very simple definition. This type of isomerism arises due to the presence of different alkyl chain on each side of the functional group. It is a rare type of isomerism and is generally limited to molecules that contain divalent atoms such as sulfur, oxygen, and sometimes nitrogen also can show this isomerism, nitrogen containing compound. For example, ethoxyethane. In the first one compound, 2 carbon are present on the left side of the oxygen and 2 on the right side of the oxygen. But in the second one, methoxypropane, the position of oxygen change and shift to one side. So now there is a 1 CH3 and there's another side there is 3 carbon. We call the CH3 with oxygen methoxypropane. So these are the metamerism of each other because having the same molecular formula, but we can't call it the chain. Actually, chain isomerism is totally different from the metamerism. So please don't confuse. Next is tautomerism. Tautomerism. Tauto means something in movement. So what is in movement? A tautomers of a compound refer to the isomer of compound which only differ in the position of proton and neutron. Typically, the tautomers of a compound exist together in equilibrium and easily interchange. It occurs via an intermolecular proton transfer. An important example of this phenomena is ketoenol tautomerism. For example, suppose we have CH3 CHO. We can write CHO like this, clear? You see, I'm changing the position of hydrogen which is present at the alpha carbon. I'm making it like this. you see that keto group change into in and ol. That's why we call it keto-enol tautomerism. So there is a condition, the compound must follow that condition, then it can show the keto-enol tautomerism, and that is there should be free alpha hydrogen available. Alpha hydrogen means the hydrogen which is directly attached to the carbonyl group. And second one is that the alpha carbon should not be attached with any unsaturated bond, either double or triple bond. It should be always attached with a single bond. Then the compound can show the tautomerism. You see, I'm giving you one more example. It will help you to clear the concept. Suppose I'm having the compound structure like this. Compound structure like this. Can this compound be show the tautomerism? No. It is the alpha carbon. Here it is the alpha carbon, and definitely there is also the double bond present between this side. Alpha carbon, alpha carbon. Actually there are 4 alpha carbon. Actually why I don't know why this double bond moving again and again from this position. This compound will not show the tautomerism because alpha hydrogen is available. There is no doubt every position contains one hydrogen. There is a one hydrogen, there is a one hydrogen, but you know that alpha carbon is attached with the double bond, so it will not show the tautomerism. Now let's move the last, that is the ring chain isomerism. For example, propene and cyclopropane. Propene having general formula C3H6, in same formula is present in the propane, cyclopropane. Now let's move for some example. Some question from the same unit. Draw the structure of all isomer having general formula C4H9Br. It is your homework. I'm helping you. C4H9, the first compound will be 1-bromobutane, in second will be 2-bromobutane, and third will be 2-methyl, 2-bromopropane, and the fourth one will be 1-bromo and 2-methyl propane. So you can draw the structure of all the isomer. Now next question is, for a molecule to show tautomerism, it is compulsory that it has, to show the tautomerism, it has alpha hydrogen and should not be attached with, there are options also, should not attach with the unsaturated or sp2 or sp hybridized carbon. Clear concept? Now I'm waiting for your response, and I hope that it was very interesting, and I'm hoping also that it was useful lecture for you. Thank you very much, dear friends, and continue, please.